Hello, Legacy Sabers. Marsh here. So today we're going to talk about function basics. So what makes a function, how do you find domain, how do you find range, things of that nature. You're going to want to have your notes out. You're going to want your writing utensil and then a calculator. So first, learning targets that we're going to be doing today. We're going to be stating domain and range of a relation. We're going to determine if a relation is a function, and we're going to evaluate a function given function notation. Our essential question today is, what is a function and how do I know if something is one? There's a box in your notes with this symbol right there. Go ahead and write that in that box. So, some definitions that we need to get through first. A relation. A relation is just a set of ordered pairs with a domain, aka x values, and a range, aka y values. So, it's just a set of related pairs. Now, a function is a very special relation. A function is where you have each value in the domain is paired with exactly one range value. Now, you're probably thinking, what does that mean? What that means is that each x has exactly one y value. Okay, so think about what that means. That means each x value that you have has to have only one y value connected to it. We're going to be looking at what that looks like here in a minute. Okay, so we're going to do some examples, finding domain and range, and also determining something's a function. You're going to want to pause the video here, and you're going to want to make sure you get this information down. I'll wait here. Did you write it down? I'll wait a little bit. Okay, you should have paused the video. You should have written this down. So now, when we're doing domain and range, as we said on the last slide, we said domain is the x values, range is the y values. It's alphabetical, if that helps you remember. So domain, we need to list the x values in numeric order. So that means in starting with the smallest, going to the biggest. And then we also need to make sure we don't include duplicates. And we also need to make sure that we do it in a certain notation. Now, the notation looks like this. First, we're going to say, hey, I'm finding the domain, aka d value. Put the colon, aka smiley face eyes, and then a curly bracket or a curly brace. Okay, squiggles work just as well. I'm going to put the numbers in the x column in numeric order. So 0, 1, 2, 3. Just like that. Now we're going to do the exact same thing, same rules for the range, it's just the y values. Now notice I can't go this way, can't go 2, -1, I can't list it like that because that's not numeric order. I got to start with the smallest. So I'm going to start with, there we go, -7, -4, -1, and 2. Just put that in that order. Now, to determine if something is a function or not, your best way to determine is you're going to look at the x values and you're going to make sure that there's only one x each time. So that means you're going to look at the x column and you're going to make sure that each x is unique, only listed one time. So for example, in this case, everyone's only listed one time. This is, in fact, a function. Here would be when it wouldn't be. So let's say this first guy was a 1. Notice 1 is going to 2, and he's also going to -1. Remember our definition of a function. Each x has its own unique y. Well, it doesn't have a unique y, does he? He goes to 2 and -1. That would mean he wouldn't be a function. So in this case, every x has their own y. So we're going to say, yep, this guy is in fact a function. Now let's try from a set of points. So I'm going to label which ones are the x values first because I got to find my domain, right? So I'm going to underline the guys that are my domain so that I don't make a mistake. So I'm going to put these guys in order. -2, -1. Oop, I got 2 zeros. But remember, you don't include duplicates because like if you get sent to the store and you want eggs, right? The person on the list doesn't write egg, 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 egg. No, they write eggs, right? So we're going to list it only once. This is a list of things that showed up, not all of the lists constantly of everybody. So we're just going to put 0 and then a 1. Then we're going to do another curly brace. I now need to list my range values, my y values. So I'm going to go above just to kind of help my eyeballs again figure out which one's which. Do my curly brace. -3, -1, 1, 3, and in fact 5. There we go. I've listed my domain, listed my range. Now, remember our trick. To determine if something's a function, you're going to look for doubles in your x values. And we got that. Now, you then want to check, do they have different y values? Yup, that's a no-go. Can't have that happen. Each x has to have only one y attached. 0, he's being greedy. He has a 1 and a 3. He can't have that. That's not allowed. So this guy is not a function. So what if the points are already graphed? What if you have a graph? Well, in that case, we're going to use what's called the vertical line test. The vertical line test is a relation to check to see if a relation is a function. What you're going to do is you're going to draw a vertical line, and it can only pass through one point at a time. So each graph, if you take a vertical line, aka like a pencil, and you go left to right, your graph, the line that's been drawn, can only cross through that vertical line once. Very easy test to find. Go ahead, make sure you get that definition down. Remember, you can pause the video to make sure you can get everything down. So what we're going to do is we're going to take a pencil, we're going to move it from the left to the right, and we're going to see if we cross more than one point. If it does, then it's not a function. So, would this graph be a function? Notice there's no pencil up here. You don't need to write this down. Let's just pay and look. So, if I have my pencil, will this be a function or not? No, right? Because right here, my pencil's moving around. We're good there. Right there, we hit twice. That's a no-go, right? Because I hit the graph twice at the same time. Thus, this would not be a function. Let's try another one. Is this graph a function? Move my pencil across here. Right there, I only hit once, right? Notice I'm just looking at that pink line. Only hit one there. This is, in fact, a function because I only hit the graph once, no matter where I drew that vertical line. Let's try another one. What about this guy? Bring out my pencil. He's not a function, right? Because if I draw my points right there, boom, boom, I hit twice. That is not a function because I had the vertical line cross the graph twice. Easiest test in the world, right? Now, let's get further on to what is a function notation. Very important stuff for us. Often our function rules are written as what's called a function notation. Now, function notation is just a fancy way for us to notate that their function has a name. So our function notation looks something like this. F of x equals 3x plus 4. Now, f is just the name of the function. So for example, this function's name is Fred. We're going to say hi to Fred. Hi, Fred. Okay, this is function f. Just so that we have a name for it, it's easier for us to refer to him. That x value is an input value. That is what we're going to see as a variable inside the function f, inside of Fred. That x value is going to be in our mathematical rule, our function rule, so that we know where certain things will be. What is the law of f? What is f's math sentence? And we read this notation as the value of f at x, or you're going to hear me say a lot, f of x. x. That's what you're going to hear me say for English when we read that notation. So for example, maybe this would turn into a g. Then that would be g of x. That means our function's name would be g. What this allows us to do is it allows us to have a lot of different math in front of us, and still we can say, you know what, I want you to use the function g, or I want you to use the function j. It gives you the ability to talk about math easier, and it also allows us to reference math sentences. Let's practice a little bit of function notation. So here we have an F and a G. So this is Fred, this is George, okay? And they tell us to find f of -4. Now, f of -4, what this means is inside of the function f, for every variable you see, you're going to substitute a -4. So that means over here, into f, I'm going to put, where I see an x, I'm going to put a -4 in its spot. So I'm going to rewrite my problem. I have -3. Oop, I saw an x. So I got to put -4 instead. Notice how I'm putting parentheses to show that I substituted -4 in. I popped -4 into there to make me note that I needed it. I'm going to add 7. Now I just got to do some simple math. This 100% calculator time, or our brain math, mental math. -3 times -4, that's 12, plus 7, our answer, 19. So f of -4 is equal to 19. Let's try g of -1. So that means for every x, I'm going to put a -1. So right here's an x, right here's an x. I'm going to rewrite my problem. Whoa, decided to zoom in there. There we go. So -1 squared plus 2 times -1 minus 10. Notice I took -1 and I put it for the full x. That squared still is going to sit there though. Now, -1 squared. Remember, squared means multiply by itself. So nice, you better write it twice. So -1 squared is -1 times -1. That is just a positive 1. 2 times -1, that's -2. Minus 10, let's do some math. 1 minus 2 is -1, minus 10 is -11. And that is the end of this video. I know function notation can be a little bit confusing here and there, but we are going to continue using it throughout the year. So this is something that we really want to get good at so that it's an easy content for us as we continue to study Algebra 2. I hope you enjoyed the rest of this video, and I will see you later, Sabers.